Hi everyone. In this video, we're going to solve the rest of the integration worksheet. And in the last video, we solved the area section of this integration worksheet. And in this video, we're going to solve the volume part. And again, there will be a third video for this series where we will solve the rate of change of this entire worksheet. And again, all the questions that are available on this question are from the year of 2019 to 2022, including the R papers. Also, if you anyone want to find out, want to have this solved PDF or even the unsolved PDF, they can also ask my page at Excel Easy to get a file of this PDF, or they can also email me directly in my email address given in the description box to get this PDF. And we have our chapter-wise booklet and our formula booklets available. In the chapter-wise booklets, they will have your questions compiled from each chapter taken from the year-wise question paper. And your formula booklets are actually a list of all the questions that will come across with all the formulas that will be needed for you for the pure maths IGCSE. Okay, then let's start. This is the same worksheet we solved for the area section. Now we're going to solve the volume section from this worksheet. So from here, we will start our video. Now, in this volume part, like unlike your area section, there were no specific formulas or something related for the area. But for volume, they have specific formulas. For example, whenever you want to calculate the volume, that object will always be rotated either by either through x-axis or through y-axis. Whenever they're going to rotate that area through x-axis, you have to use the x coordinates. And whenever they're going to rotate the area through y-axis, then again you have to use the y coordinates. So for example, maybe there's an area that is in, sorry, not area, there's a volume enclosed with a line and a curve, and this specific region was rotated through x-axis. Then what you would do is that for volume in that case, it's going to be y square pi, and the boundaries over here are going to be the x coordinates, x2, x1. Okay, it's always pi y square dx. And again, the y square equation has to be written in terms of x values. And again, for volume, like this was the equation that we're supposed to use if the volume was rotated 360 degrees through x-axis. And again, similar working will have to be done for the volume if it is rotated through y-axis. In that case, the formula would be y2 minus y1. This time, we're going to use the y coordinates for this graph, and it's going to be yx squared dx. Now, these are the two formats of the volume calculation. You have to specifically focus on the fact that where in a question they're stating that if your area or volume is generated through or rotated through x-axis or y-axis. For example, in this question, this is taken from June 2019 2PR. This was actually a concept for area for volume rotated through about y-axis. So if it is rotated about y-axis, that means over here. Now you're just going to get concerned about the y-axis coordinates, not for the x coordinates. Now let's read the question first. It says that the finite region R is enclosed by the y-axis. The y-axis, the straight line with equation this, and with the curve with equation this. This is a quadratic graph and is defined for points with coordinates x, y, and x equals to 0, greater than equals to 0. Okay. Now we have to first imagine our area or a simple structure of the graph that would be that could be drawn for this situation. For example, over here, you have a quadratic equation crossing through the x-axis at point 2 exactly. This is minus 2. And again, you have this coordinate of y plus 2x equals to 13. I'll just make y the subject of this equation. So it will look like y is equals to minus 2x plus 13. In this way, it's just easier for me to work with because now I can understand this is going to be a downsloping straight line where the graph would meet the y-axis at 13, right? Because it has the y-intercept at 13. So the straight line in that case would be like this. This is 13. And again, you can clearly see that the curve meets the straight line at two distinct points. But on your question, they have clearly stated that your x coordinate should be greater than and equal to 0. Right, over here, your x coordinate is 0, but in this situation, right, in this situation, your x coordinate is greater than 0, which is also following with your range, but this coordinate is not following with your range, because in this case, your x coordinate is less than 0. So that not be taken into consideration for this maths. So I think we'll first find out the intersecting points over here. For example, for intersecting points, I'll just use this part that y is equals to minus 2x plus 13. This is considered as equation 1, and y is equals to x square minus 2. This is considered as equation 2. So equation 1 and 2, I have to substitute 1 into 2 in that case. I'll write substitute 1 into 2. Now it will look like x square minus 2 and then minus 2x plus 13. So you have x squared plus 2x minus 15 equals to 0. Now this is a complete quadratic equation. From this point onwards, you have to do the factorization. So it will be x squared 3x plus 5x minus 15 equals to 0. So you can take x common, x minus 3 plus 5, and then x minus 3 equals to 0. So x plus 5 and x plus 3 equals to 0. Finally, you can write that the coordinates are x equals to minus 5 and x equals to positive 3. Obviously, we're not going to take the negative x coordinate because on your question, you have stated already that the x coordinate value should be greater than or equal to 0. So we're going to take that x equals to 3 as one valid equation. So it's going to be, for x equals to 3 again, you have to find out the y coordinate, corresponding y coordinate for that coordinate. So we're going to write substitute x equals to 3 into 1. I'm going to substitute this into 1 because it's easier to work with. Or you can also substitute this into 2 also. Same working should be done. Y is equals to 3 square minus 2, which is 9 minus 2, so 7. So you get one coordinate from this section, which is 3, 7. And there was also another value for x available, which was x equals to 0. Right, from this range, you can clearly understand x equals to 0 or x has to be greater than 0. Now we got the value for x greater than 0, which was 3, and we also calculate the corresponding y coordinate for that value also. Now we have to find out the corresponding y coordinate for this x equals to 0. So now I have to just substitute that. Substitute x equals to 0 again in equation 2. So now you have y 0 square minus 2, which is again just minus 2 in this case. So for your graph, from your graph, if I just take this to the left a little bit. So from your graph, this time, if you focus on exactly what region they were talking about to calculate the volume for, they were talking about this region over here specifically. Between y-axis, curve, and straight line, right? They never stated anything about x-axis being the boundary. So this is how this is the region in which they're focusing on to calculate the volume for. Again, this region will be divided into two sections. The first one is this one. The first one is this section, which is completely a straight line. Like this entire region is actually composed of all straight lines, right? So we can think of it as a triangle. If this was for area, then we could have considered this as a triangle, right? But as this is a volume should be like three-dimensional. Okay, so as we were saying that highlighted section could be considered as an area of triangle if we were working for area section, but as we were considering for volume, so now we will consider this as a like cone in this situation. But I think using the formula of cone for this situation is tough because you have to use 13 by 2 as the radius, 7 as height. Not exactly 13 by 2 should be used. You can consider this as half of a cone, right? So in that case, 13 would be the radius. Like this is the radius and this is the height. And formula for volume of a cone is 1 by 3 pi r square root. But this time, this entire formula will be divided by 2. But I think that's just way more lengthy to work with. What we can consider separately over here is that okay, the upper part is a different section. And in this case, the boundaries are what? 13 and 0, right? As in this situation, the area was rotated through y-axis. So we have to only consider the y coordinates this time. So for the blue section of this volume, we will only consider the 13 and 0 as the possible boundaries for this section. And again for the red section, between the y coordinate, x coordinate, and your curve, this time the boundaries would be 0 and minus 2, right? Because you can clearly see this is 0 over here. This is 0 and this is -2. Or wait, 1 minute. Sorry, the coordinates were not 0. When x equals to 0, y was -2, and when x equals to 3, y was 7, right? In this situation, on my graph, it looks like that maybe the curve and the straight line were intersecting at x-axis, but in real life, actually, they were intersecting at x equals to 3, where y is equals to 7. Okay, so I think I should just, clarify this a little bit. Okay, now I will draw the x-axis quite a bit lower than this. Maybe here the x-axis is present for this curve. And now in this situation, I have to dissect this entire journey. Above the black line, that is your blue region, and above the black line, so below the black line, that is your red region. And this is a coordinate of 7. In that case, the coordinates, y coordinates for this boundaries would be 13, 7, 7, and -2. Again, for the blue section, it is only enclosed by your straight line, and for the red section, it is only enclosed by the curve. So the final volume equation would look like this: that volume pi. At the end of the day, this time you have to add the two volumes together, right? So it's going to be 7 minus 2 pi. Remember that now you have to use x squared in this situation because it was rotated through y-axis. So your equation should have y inside them. So it's going to be x squared for the curve, and then again 7. So it's the upper boundary for the line would be 13 and 7 pi, again x squared, but we have to break down the equation further. So which will look like 7 minus 2 pi. For x square, you get from this equation, if you just make x square the subject, that will be y plus 2, right? So you have y plus 2 plus 13, 7 pi. For x square in this situation, it will be y by 2 minus 13 by 2, I guess. Sorry, it's actually going to be from this equation, if you just make x a subject, that will be 13 by 2 minus y by 2. In that case, now you have 13 by 2 minus y by 2. Right, I will just, copy this and take this entire calculation to the next page, because it won't have much space over there. Okay, so now from this page onwards, I will try to do our normal integration. Right, another thing that you have x square over here, right? This was not an x square. So you have to break down this x square in this case. So now you have pi. If I just write this over here for one another line, it's going to be y plus 2. No need to do x square over here because already the equation was for x square. So no need to do square for the first term. But for the second term, it's going to be 13, 7. Again, I'm going to take the pi at front. And now you have 13 by 2 is actually 6.5. So now you can write that 6.5 square is actually 169.4. 9 by 4, and then again 6.5 into 0.5 into 2 is just 6.5y, so you have 6.5y, and then finally for this case it's going to be y square divided by 4, right? Okay, and after this I'm going to integrate these equations. Again, pi can be taken as a common from here, so it's going to be y square by 2 plus 2y. This is one integration part where boundaries would be 7 minus 2. And then again, in this case, we're going to have 169 by 4y minus 6.5y square by 2. And over here, it's going to be y cube by 3 multiplied with 4 is going to be 12. And obviously they have seen in them constants in them, but as these are integration with boundaries, so no need to actually write that constant c, because it will be eventually cancelled out along the equation, right? So this is with boundaries of 13 and 7. 13 and 7, okay. 169 by 4y, and then 6.5y square by 2, and then this will be positive. y power 3 divided by 12, right? Because 3 multiplied with 4 is eventually going to be 12. Now we're going to input the values of the like coordinates in this part. That's going to be 7 square by 2 plus 2 7 minus 2 square by 2 plus 2 minus 2. And again, this has to be added with pi 169 13 divided by 4, 6.5 13 square by 2 plus y, not y, this time we're going to write just 13 cube by 12. And again, this has to be subtracted from a similar kind of equation where the values of x would be 7 this time. Right, so I'll just change inside the brackets. Now it's supposed to be 7, 7 square, 7 cube, right? And that's just it. From this point onwards, you can just have your calculator to calculate all these parts. So you have 7 square divided by 2 plus 2 multiplied with 7. That is 77 by 2. And then again, you have to subtract that with minus 2 square divided by 2 plus 2 into minus 2. 89 by 2. That's what you get for the first part. 89 by 2. Wait 1 minute. And let me just recheck. 7 square by 2 plus 2 multiplied with 7. And then minus 2 square divided by 2 and plus 2 multiplied with minus 2. Right. So you get 81 by 2. Yes, 81 by 2. So you get 81 by 2 pi for the first section. And for the last section, you have 169 multiplied with 13 divided by 2 minus 6.5. 6.5 multiplied with 13 square divided by 2. And then again plus 13 cube divided by 12. This has to be subtracted with 169 multiplied with 7 divided by 2. So divide by 4. Right, divide by 4 and then again minus 6.5 multiplied with 7 square divided by 2 this time. And then plus 7 cube divided by 12. This for the last section from this entire part, actually you get 18 pi. So I think in your question they asked you to keep your answer in terms of pi. Right, yes, in terms of pi. Right, your answer should be in terms of pi. In that case, you just have to like add 18 and 81 by 2. So this with 81 by 2. Now you get 50.5 pi. This is volume, so the unit should be unit cube. This much pi units cube. So with this, our working for the first question ends. I hope it was clear enough for all of you to understand. Let me just give you a last recap. But we just draw that image over here just to give you an idea, visual idea about how to visualize which section you're working with. I'd always ask you to draw a diagram over here because it's just easier for you to understand in that way. We first found out the intersecting points. We found out the y coordinates for the intersecting points because that was what we needed. And using this intersecting point and the image, we divided the volume into two sections. First one is the blue section only regarding the straight line, and the second one is the red section regarding the curve. And using the boundaries of each section, we calculated the integration over here. And obviously, you cannot use just on a calculator and do the integration and just tell you the value, like tell us the value at the end of your entire answer. You have to show all the steps over here because we're not supposed to use calculator for integration, like for this specific integration calculation. Okay, then we will move on to part 2. This is from November 2021, paper 2. Let's start. The finite region enclosed by the curve with equation y is equals to 4x square, and the line with equation this is rotated through x-axis. This time they're rotating through x-axis. That means we have to work with the x-coordinate of these intersecting points, and we have to use algebraic integration to find out the exact volume for the solid form. Again, as I've already stated, draw the image of this kind of curve if that image is not given to you. So we will draw an image. This time you have a negative quadratic graph where it crosses the positive 4, right? Yeah. This is positive 4. And again, you have a coordinate of y is equals to x plus 2. In that case, the straight line is supposed to look like this, where it specifically crosses the y-axis at 2. Now, in this situation, the volume that was enclosed in this part was between the finite region enclosed by the curve with equation atho and the line with equation atho. Okay, so it was only actually enclosed by the curve and the straight line. It was not bounded by x-axis or y-axis. So in that case, we are only focusing on this entire section. In this total section, and we can clearly understand that the curve and your straight line are intersecting at two corresponding points, and obviously as we are trying to find out the volume for this section, you have to find the volume between these two coordinates. On, for example, if this coordinate is like b and this coordinate is like a, your boundaries over here is going to be b and a. Another thing, in this region, the area is actually going to be a subtraction for curve minus straight line, because the curve is above the straight line, right? So if you're going to find out the volume for this curve, it will calculate all this volume, right, including this lower section. You have to subtract the lower section by subtracting the volume of the straight line. Only then you'll get this shaded region volume. So we will first start trying to find out the intersecting points coordinate. Now we have equation of y is equals to 4 minus x square. This is the first equation, and y is equals to x plus 2. This is the second equation. Now with these two equations, you have to use substitution from this point. So it's going to be substitute 1 into 2. So now you have 4 minus x square equals to x plus 2. If you arrange everything in one side, it will look like x square plus x minus 2, because 2 minus 4 is minus 2 equals to 0. From this point onwards, you just have x square minus x minus x minus 2, 0. Wait. Right. Then you can write x common, and it will be x plus 2 minus 1 common, then again x plus 2 equals to 0. So you get x minus 1, x plus 2 equals to 0. So now you have two coordinates for the intersecting points, x equals to positive 1 and x equals to negative 2. Again, in this section where we were generating this solid and rotated this solid through x-axis. So obviously we have to just use the x coordinates. The y coordinates are not important over here. So we will not waste our time trying to find out the y coordinates for this corresponding values of x. So from this point onwards, we'll just move on to your calculation for that integration part. Now, in order to find out the volume, let's just find out the equation of volume over here. For volume, you're going to write the obviously pi. Boundaries would be 2, 1 and minus 2 and y square, right? This is one like curve equation, and minus of this would be pi, again 1 and minus 2. Equation for your straight line was x plus 2. It's again going to be y square. So finally you have to write this as pi 1 minus 2, 4 minus x square whole square minus pi 1 minus 2, and this is going to be x plus 2 whole square. We'll just take this again to the next page for our further calculation. Okay, now from this point onwards, we first need to break down the square before we start with the integration. So now you have 16 minus 8x square plus x to the power of 4, right? Integration 1 and minus 2 with boundaries and multiplied with pi, minus pi, 1 and minus 2 boundaries. And over here, you're going to get x square plus 4x plus 4. Final section will now do the integration from this point, which is 16x minus 8x power 3 divided by 3 and x power 5 divided by 5. This is one part multiplied with pi, boundaries 1 and minus 2. After that, you have x power 3 divided by 3 plus 4x square by 2. So it will be 2x square, right, in this case. So I'll just write 2x square directly over here. 2x square plus 4x, and again this will be multiplied with pi, boundaries 1 and minus 2. The final part from this point onwards, I'll just do the integration from here. For the integration, you have 16 1 minus 8 1 cube divided by 3 plus 1 power 5 divided by 5, right? Again, obviously they have constants, but we're not going to get involved with constants because constants will be eventually cancelled out at this case, because for integration with boundary, constants always gets cancelled out. This was again multiplied with pi, and we will change this 1 inside the brackets to minus 2. So now you have minus 2 over here, minus 2, and then again minus 2. Similar working for the next part. It was subtracted this time. Previously, it was added with the first expression. Now you're going to subtract it. So now you have 1 cube divided by 3 plus 2 1 square plus 4 1. This thing again will be repeated with the values of x to be minus 2. This is minus 2, and minus 2. Right. And nothing else to do from this part. We just have to calculate this at the end. Now we have 16 minus 8 by 3 plus 1 by 5, and subtract this from 16 multiplied with minus 2 minus 8 minus 2 power 3 divided by 3, and then plus minus 2 minus 2 divided power 5 divided by 5. Okay, you get 153 by 5, 16 8 by 3 plus 1 by 5, 8 2 power 3 by 3 minus 2 by 5, 2 power 5 by 5, and then 16 multiplied with minus 2, right? So you get 153 by 5 pi for the first section. And for the second part, now you have 1 by 3 plus 2 plus 4. And this has to be subtracted from minus 2 power 3 by 3 plus 2 minus 2 square. Right. 2 minus 2 square plus 4 minus 2. So now you get 9 pi from the next equation. So this is 9 pi. So 153 by 5 minus 9 is 108 by 5, which is approximately 21.6 pi units cube. Right, so this is the volume part of your integration of the next maths. I hope this was clear enough for all of you to understand. Again, similar kind of working we did over here. We first found out the intersecting coordinates, and then using the intersecting coordinates from that image also we found out that okay, in this situation we have to subtract the areas, so we subtract the volumes, and by subtracting the integration we did the calculation for the volume of that selected region R. Okay, so that's the end for that question. We'll move on to the next question. This question is from Jan 2020, 1PR. So let's start. Over here, we can clearly see there's a region bounded by the curve and two straight lines. One is horizontal and one is vertical. Figure 2 shows a part of the curve with equation y is equals to root over x minus 2. Figure 2 also shows the straight line with equation y is equals to b, where x is greater than 0, and again b is also greater than 0. And where x is greater than 0 means that y equals to b is not a horizontal line. This is like not a horizontal line exactly on x-axis. It is somewhere above x-axis. And it is also stated that given that C and A intersect at the point P with coordinates A and B, where A should range between 0, like 2 to 16, and we need to show that the value for B square can be written like this also. Okay. Now this is the point P, right? You can clearly understand the y coordinate would be B and the x coordinate over here is going to be A. So we can write in this section as A. Also, the area that was shaded in this section, whose volume we would have to calculate, is also in between the range of A and 16. We can clearly understand. So let's first find out this expression of B if we can find out. For this case, I just have to substitute the equations over here. That's just it. For example, in part A, the equation was y x minus 2 root. Right, this is equation 1, and y is equals to b is equation 2. So if you substitute 1 into 2 or substitute 2 into 1 specifically, so now you have b x minus 2 root, which is going to be b square x minus 2. And again, at point P, the x coordinate was A. The value for x coordinate was A. So you can clearly input the value of that point A over here. In that case, or think of it like this. I think it would be better to rewrite it again. For example, we're going to just substitute the point P coordinates in the equation. So we'll just write substitute P into equation 1. This is equation 1. The coordinate for P were A and B. So instead of writing Y, we'll write B, and will be A minus 2 root. Because for that coordinate of P, B was the Y coordinate and X was the A coordinate, right? And A was the X coordinate. So we're just going to substitute Y in the place for B, and we're going to substitute A in the place for X. So finally, you can write B square A minus 2. And this was the equation that you had to show. And we're done doing that. So that's it. For part B, again, it says that the finite region bounded by C straight line with equation x equals to 16 and line shaded in the figure 2 rotated 360° about x-axis. Again, if it is rotating through x-axis, that means we have to use the x coordinate in this situation also. And it is also provided that the volume of the solid formed is 50 pi. We have to use this 50 pi to give you a value for A and B. Okay, now in this section, we can only understand that the higher boundary over here is going to be 16, lower boundary is A, and the region over here that is shaded, it is what the curve is above and the straight line is below. So it's just going to be C minus the straight line, C minus line L. So now from this part, we'll do the calculation for part B. So again, for volume, that will be 16A. Your equation was y is equals to root over x minus 2, right? In that case, we have to use y square. So root over x minus 2 will eventually just become x minus 2 because square on top of a root will cancel each other out. So now you have pi y square minus again 16 and a with pi y square. Right, the first equation would be pi 16a, y square would be x minus 2, and over here again pi 16a, y square in this case is b square. But remember the value for b square was a minus 2, right? We'll just write it again, b square, which is eventually a minus 2. This is your second expression. So instead of writing y square or the value for y square, which is b square, and again substitute that as a minus 2, I'll just directly write a minus 2 over here. Finally, we have to integrate this. It's going to be x square divided by 2, square divided by 2 minus 2x with the boundary of 16 and a. Remember that over here the boundaries are quite similar, so you can take common in this section because every boundary for the two integration are similar. And again pi, this will be ax minus 2x with the boundary of 16 and a. We can clearly understand that the 2x over here will eventually get cancelled out. Finally, we'll be left out with, or I think let's not do that over here because it will just make things more confusing for you to work with. Let's just keep it this way and input the values. It will be 16 square by 2 minus 216 and then minus a square by 2 minus 2a. Right, and finally you have minus. No, I think taking common over here is going to be a very good thing. It will just make your maths less lengthy and complicated. From this part onward, we can first take pi common. In that case, if you take pi common, now you have inside the brackets this x square by 2 minus 2x. Right. I'll just take everything inside one bracket because they all have the same boundaries. So it's just x square minus 2. So divide by 2 minus 2x and then minus ax. On this minus minus, you have plus 2x with the boundary of 16 and a. Right. So from this part, we can clearly understand 2x gets cancelled out. Now you're left with pi x square by 2 minus ax with 16 and a. Now it's just more easier to work with. Also, it was already provided that the volume was 50 pi. So you can clearly understand that this pi and this pi will be cancelled with each other. Now you have 16 square divided by 2 minus a16 and a square by 2 minus a square, and this is also equals to 50. 16 square divided by 2 is 128. 128 minus 16a, and from this part you have, a square minus a, you can do LCM over here or you can just keep it like this. A square minus a, right? So half a square minus this is half minus 1 is just going to be negative half. This is going to be positive half. A square equals to 50. Obviously, you have to do middle term, but before that, we have to multiply everything with 2, which would make a square 16 multiplied with 2 is going to be negative 32a. And then again, 128 multiplied with 2 is 256 minus that 50 on the right hand side would also have to be multiplied with 2. So it's going to be just 156, positive 156 equals to 0. So if you do middle term from this part, it's 1 minus 32, 156. Wait. So they were asking for one value of a, right? 16 and a, 16 and a. This was minus, right? So x square by 2 minus ax. So this is 16 square. 16 square divided 16 square divided by 2 is 128, and then 16a minus a square by 2 minus a square, right? A square by 2 minus a multiplied with a would be a square. So half minus a is half a, and this is half a square. (156) positive 156. Okay, over here, if you middle term it, 1 minute, I think I got the answer. The value for a you get is either 26 or 6, right? Now, in your question, it was already given that the value for A must lie between 2 to 16. So from this part, if you do carry out the middle term, it will be the value for A is going to be either 26 or the value for A is going to be 6. Obviously, we're not going to accept this because A ranges from 16 to 2. It should be greater than 2 or less than 16. So obviously, I'm not going to accept that value for A. In this case, the value for B would be also provided to you. For example, the equation for B that you calculated was A minus 2, right? So now you get, I'll just do the calculation over here. For B square, that's going to be A minus 2. The value for A is 6. 6 minus 2 is 4. And obviously there was a square. You just take this square to the right hand side. The value for B is 2. And we can clearly understand where the value for B over here is going to be just the positive value, not the negative values. Because on your graph, B was drawn at the positive axis, positive y-axis. So yeah, that's it. Again, another thing I skipped, you have to do the factorization over here. Do not skip factorization for maths. So obviously show the factorization in this section, which I skip, but you're not supposed to skip it. I'll just write factorization. So if I zoom out, this is how the final volume looks like final integration volume part. And using the volume, we calculate the value for your A and B, unknown alphabets A and B. Okay, so yeah, that is it. We'll now move on to the next question. Let me see how many questions are left. 1, 2, 3. Okay, 3 more questions from this volume part. Okay, now for the first part over here, it says that fx is 32x power 3, 33x and 1. Show that f1 is equals to 0. You need to show just that the value for x is root for this equation. So let's just do part 1 over here only. F1 32 1 cube minus 33 1 plus 1, that is going to be 32 minus 33 plus 1. This is again 33 minus 33, right? So 33 minus 33, final answer would be 0. So we did proved this. And hence using algebraic expression, the algebraic method, find fx equals to 0, you have to do factorization. I think for this math, factorization will not be applicable. We might have to use the formula method for factorization. Okay, so now you have the equation as, for part B, 32x square minus 33x plus 1 equals to 0. And the value for x in that case would be 33 plus minus root over 33 square minus 4, 32, 1. Divided by 232. So now in this part you get inside 33 square minus 4 into 33 is actually 961. So you have 33 plus 961 under a root divided by 64, and then again 33 minus 961 under a root divided by 64. So then again you have 33 plus root 961 divided by 64, which is either 1 or the other value of x is 1 by 32. Okay, I'll just write it as 1 by 32. Okay, now these are the coordinates, right? Wait 1 minute. Right, these are the actual solutions for this. We had to solve this. We did solve that, right? So yeah, this is it. And yeah, okay. For part B, B is done. We just had to find out the algebraic factors of this equation, and we did find out the algebraic working for that factors of that equation fx equals to 0. From this part, we'll now continue solving part C and D. We can clearly see a graph over here. From this graph, there's a region R. This wait 1 minute. This is curve 1, this is curve 2, and the region R is bounded with this vertical line x equals to x equals to a, and the two curves are intersecting at point B also, right? Now in this part, the region R shows the shaded in figure 4 is bounded by curve C1 with equation y root x. This curve has an equation of y equals to root x, and the curve C2 with equation y is equals to 1 by root x. So this is y is equals to 1 by 8x. And there's obviously a straight line, x equals to a. This is the equation x equals to a. And the curve C1, C2 intersect at point B with x coordinate B. We need to find out the x coordinate of B. Okay, so in that case, we just have to, you input the equation in equation 1 into equation 2. Like substitute the equations over here. In that case, how many pages do I have? Okay. For part C, it's going to be y root x is equation 1 and y 1 over 8x is equation 2. So I'm going to substitute 1 into 2. In that case, now you have root x equals to 1 over 8x, which is basically, I'll take this root to the other hand. So it's going to be x equals to 1 over 64x power 3. I'll just take this, sorry, x power 2. I'll just take everything to the left hand side. So now you have 64 x power 3 1. Finally you get x equals to 1 by 64 cube root. The final answer for this is 1 by 4. Right, we were only asked to calculate the x-coordinate of point P. So this is the x-coordinate of point B, which is also labeled as P in your equation. So you can write that therefore P is equals to 1 by 4 because the x-coordinate of B was named as point P in your coordinate in your question. So this is the working for part C. That is it. Now we'll move on to part D. The region R is rotated 360 degree about x-axis, and to generate a solid with volume this. The volume is already provided to you. We need to use this volume and use algebraic integration to find out the value for A. We can clearly understand from this graph that over here the formula would be, like, we have to do normal integration, but this time the equation would be C1 minus C2. Right, because C1 is above and C2 is at the below, or C2 is at the bottom. So it's going to be C1 minus C2. Boundaries over here are going to be A and the value for P, which was 1 by 4. These are going to be the boundaries. This was 1 by 4, and other, higher boundary over here is going to be A. Right, so I think we can start. Nothing else to understand from that. We have to first, though, find out the equation for the square part. That is y root x. If you square this, it's going to be just x, right? And over here again, y is equals to 1 by 8x square. It's going to be 1 by 64x square. These are the two y square equations for the two curves, C1 and C2. This is for C2. This is for C1. And the boundaries were from A to 1 by 4. So it's going to be volume. But in this case, the volume part would be pi A 1 by 4 can be written as 0.25. Okay. In that case, now you have y squared is going to be x in this case, right? X dx minus pi A 0.25 1 by 64 x squared dx. From this point, we will just, again, I'll write this as like 1 by 64 or x power minus 264 by 64, because in order to integration or differentiation, I would always suggest you to keep the fractions in terms of powers. It's just easier to work with in that way. So now you have x power minus 2 divided by 64. In that case, if you do the integration, from this part is going to be x square by 2. Right, x square by 2 with boundaries of a and 1 by 4. And then again from this part is going to be minus 2 plus 1 is minus 1. And yeah, minus 1, 64 minus 1 multiplied will just be negative 64. So now you get minus x power minus 1. X power minus 1 means again it will be shifted to the denominator. Now you have 64x and boundaries are a and 1 by 4. multiplied with pi. And again, this entire volume was already calculated and given you the value as 27 by 64 pi, I think. Yeah, 27 by 64 pi. So this should be always equal to 27 by 64 pi. Okay, now we will continue with this. Over here, it's going to be a square by 2 minus 1 by 4 square by 2. Right, this is one part. Again, multiplied with pi. And over here, it's going to be 1 by 64a minus 1 by 64 multiplied with 1 by 4, again multiplied with pi. This was equals to 27 by 64 pi. Over here, 1 by 4 square divided by 2 is 1 by 32. So now you have a square by 2 and 1 by 32. This entire thing is multiplied with pi. And in this case, you have, this will be positive, right? So 1 by 64 multiplied with 0.25. You have 1 by 16 over here. So 1 by 16 minus 1 by 64a multiplied with pi equals to 27 by 64 pi. I'll obviously take this pi common. So now you have pi a square by 2, 1 by 34, 32, and everything on the second expression was multiplied, has to be multiplied with negative, right? So it's going to be negative 1 by 16 plus 1 by 64a at the denominator. This is also equal to 27 by 64 pi. Finally, the pi's on all the sides are cancelled out. And now you have, a square by 2, 1 by 34. So 1 by 32 and 1 by 16 are actually going to be added together. And you're left out with 3 by 32. So negative 3 by 32 and 1 by 64a is equals to 27 by 64. I'm going to take this 3 by 32 on the right hand side also. Now we have a square by 2 minus 1 by 64a, 27 by 64 plus 3 by 32. So 27 by 64 plus 3 by 32 is actually 33 by 64. So a square by 2, 1 by 64a, and this is 33 by 64. On the left hand side, we have to do LCM this time now. Oh, wait, don't have much space. I do not know where to continue. I'll just continue from here, okay? Now from this part again, we will have, if you do the LCM over here for 2 and 64, 264, we can take 2 common 1, and then 64 by 2 is just 32, is again going to be 64 at the end, right? So now on the denominator, you have 64, 64a actually, and over here you get 32 a square, yeah, 32a cube in that case over here, because it was 64a, right? So 64a divided by 2 is going to be, wait, over here a, right? So in that case, it's going to be 32a with a square, so that 32a cube minus 1 divided by 33 by 64. Final case where I'll just, take all the 64 to the right hand side. Now you have 32 a cube minus 1, 33a. Finally, you can write 32 a cube minus 33a. Sorry, this was actually positive over here, right? So this was plus. So this was, sorry, this was negative. This is plus equals to 0. But on your equation, the very top, you had 32. Oh, wait, I made a mistake. Didn't actually realize we have this 32x cube. So in that case, our calculation for this one is a little bit wrong because I consider this as x square. Sorry for that. We'll again come back to this, but we actually need this calculation for the later part. So for this situation, actually, 32x power 3 minus, okay, sorry, 1 minute. Let me just do this calculation over here real quick. We have this as 32 x power 3 plus 0x squared because x squared coefficient was missing over here. So minus 33x plus 1, 0. Now if you do the middle term from this part, 2 and then 3 over here, degree is 3 in this case. 32, 0 minus 33 and then 1. So now you get 1.03 1 and again in decimals. Okay, so at first we can break this as 32x cubed plus 32x squared 32, so this is going to be if this is 30, yeah, this is going to be 32x and then x plus 1 0. Right, so we can take 32 x square common, x plus 1, and then minus 32x common, it's going to be x, this is square, yeah, then x plus 1, and then minus, sorry, and then again, wait, if this is minus, sorry, wait 1 minute, this has to be negative, this has to be positive, if this is negative, negative, right? In that case, you're going to take x minus 1 as a common factor for all these cases. So minus 1 and x minus 1, 0. Right, so it's going to be 32 x squared minus 32x minus 1 and then x minus 1 equals to 0. Now from this part, for the first quadratic equation, you have to now use the formula method. I will just, shrink this or take this to the right hand side because it's just taking up too much space. Right, we'll continue that part B over here because we have to find out that value for x, which is going to be 33, so 32 plus root over, plus minus root over 32 square minus 432 minus 1 root divided by 232. Now if you do the formula over here, you're going to get 32 minus 32 minus 1. Wait, made a mistake. 32 minus 32 minus 1. So you get 4 plus 3 root 2, 8. And the other value is 4 minus 3 root 2, 8. And from this part already you got x equals to 1. So obviously we're going to value, like for the value of a, we're going to use that x equals to 1. Because if you go back to your graph, right, the value for a should be greater than 0.25, right? And these values you're getting actually are either 0.03 negative or 1.03 positive. Right, it is like 1.03 and over here it's going to be 0.03. So obviously these are not values. We're going to take the value for a is x equals to 1. Because if you remember, this is the exact equation we got for that part D after the integration. Right, so over here after all this integration, we got that same value, 32a cube minus 33a plus 1. So if you do the same working, we do not need to carry out the same working again. From we can just now at this point say that a is equals to 1. The final value for a would be 1 because we're using the concept of part B. Right, they were related. So yeah, that's it actually for the entire working for this question. Quite lengthy and time consuming and space consuming also. Yeah, so that is it. We'll move on to the next question. This is from June 2022 P. The region is enclosed by the curve with equation y is equals to e power 3x, and the x-axis, y-axis, and the line with this equation, it is rotated 360 degree about x-axis. Now this time we have to keep your answer in terms of pi and in terms of e. So over here, obviously, I'll draw a graph. Okay, sorry. As I was saying that from this part, I will have to draw a graph like this. This is the overall shape of an exponential graph, right? Y is equals to e power 3x. And again, this area was represented by x equals to 3, another straight line. The area in which we were only focused about is this section. Area enclosed by x-axis, area enclosed by y-axis, by that x equals to 3 line, and the curve. So this is the equation for curve, y is equals to e power 3x. This is for x equals to 3, and this is the y-axis, and this is the x-axis. Now, we can clearly understand the boundaries over here are going to be 3 and 0, right? This is 0, and the other one is 3. So we just have to do the integration from this part onwards. Nothing else to understand or explain in this maths. It's quite easy. So I'll just write volume is actually pi 30 y squared dx. Y squared dx means you had e power 3x. This time it's going to be e power 6x in this case. So y power 6x, again, if you integrate y power 6x, it's just going to be 1 by 6 e power 6x. The powers will not be added in this case. So it's going to be e power 6x divided by 6, and the boundaries over here are 3 and 0 multiplied with pi, which is 3 into 6 is 18, right? So now you have like pi e power 18 by 6, and then e power 0 is what? Just 1, right? Let me just check. I think it is 1. E power 0 is 1, right? So now for e power 0 by 6, I'll just write it down over here. And in the next line, I'll write e power 18 by 6 minus 1 by 6, everything multiplied with pi. You can keep your answer like this, or you can take that 1 by 6 common, and you can also write 1 by 6 pi e power 18 minus 1 inside the bracket. But that all the corrections, like all the formats are acceptable over here, because in this case, you just have to write your answers in e power, right? That's what we did. Nothing else to do over here. Okay, then moving on to your last question for this integration worksheet. Right, in this. Okay, so we will solve question 11, the last part of this integration worksheet from volume. Question 11 was taken from June 2000. This is actually a typing mistake. This is actually taken from June 2021 to B. Okay, this was the original question year for this question. Now over here, we can clearly see that we have two graphs again, one with equation of y is equals to e power x. This is the y is equals to e power x, and the second one is y is equals to 4 e power minus x. This is the second graph. The straight line with equation x equals to a, and the x-axis and the y-axis, like the area or the section, the shaded section over here is bounded by the curve 1 e power x, curve 2 e power like 4 e power minus x, the y-axis and the x-axis, and the straight line x equals to a. This is x equals to a. Now we have to find out the volume for this specific region, but it is also stated that the region was rotated through x-axis, so that means we have to use the x coordinates in this situation. And other than that, if you find out the volume should be written in this format. Okay, so basically in this part, they want you to find out the value for a and k, but I mean, without actually regarding any like solutions from this part. You just have to start solving the integration part, and at the end you have to keep your answer in this format: k minus 8 pi e power minus 4x. Like that is a format in which you should keep your answer in. And then by just using similarities, you can find out that okay, in the position for k, if you have like 7, then the value for k would be 7. That is the final case that you have to do in order to find out these alphabets. Now, before we waste any more time, let's do the working. Now, again, over here, obviously we can understand that this region is like surrounded by curve 1 and curve 2. But curve 1 and curve 2 intersect at this section. And over here, it'd be better if I would divide this section into two parts. Like this one is first part that is divided in between, like that is actually situated in between the y-axis, x-axis, and the curve one, which was y is equals to e power x. And the second section over here, this is the second region. And in the second region, the area was bounded by e power of like 4 e power minus x equals to a, and this again, this x-axis and this line over here, red line in this case, right? This is the region for the second part. Now, in order to first find out the integration, I would have to find out the x-coordinate for the intersecting point for the two curves, because, for example, the x-coordinate is b. In that case, the integration for this part will be between boundary of b and 0, and for this part, it's going to be a and b, right? Because the boundaries are different for the two sections. In order to first find out the value for b, I have to intersect equation 1 into 2, or the two curve equation together. So it will be, I will start the working from here. Equation 1 was e power x. This is equation 1, and another equation would be 4 e power minus x. Let's write this as a fraction because we have e power minus x, right? That means this e power x were originally from the denominator. And obviously I have to substitute this time. So we're going to write substitute 1 into 2, that's going to be e power x is equals to 4 e power x. We're going to take every e power x to the right hand, to the left hand side. So e power x multiplied with e power x are going to end up with e power 2x. So e power 2x equals to 4. We can just take that 2 to the right hand side again, and that will be a power of half on top of that 4. So now you have e power x with root of 4. Half means root, right? So now you have again e power x is equals to 2. Again, if you take this exponential to the left hand side, sorry, to the right hand side, inverse of exponential ends up to be ln. So now the value for x is going to be ln 2. And obviously you end up with positive and negative value, but obviously we're going to stick with the positive because on your graph, all the shaded region was on the positive x-axis. So negative value is obviously not going to take it into consideration, right? So we're not going to mess up our working with the negative values included here. We just keep the answer into positive because everything is positive in this part. Okay, now we have the x coordinates, and now we have to start with the integration. For the integration, we can clearly see we have to first find out the integration of the first region and then add it with the second region, right? So that's just easy. We'll start the integration here. Volume was for e power x. Yeah, e power, sorry, I think I should write it like this, that pi ln to 0, right? For section 1, it was actually bounded in between 0 and ln 2. So these are the boundaries, and you have y square. Then this should be added with pi a ln 2, and then again y square. They have different values for y square, obviously. For pi ln to 0, it's going to be e power 2x plus pi a ln 2, and now you have 4 e power minus 6. This time it's going to be 16 e power minus 2x. And now we have to start the integration process. For integration, this e power 2 would be half e power 2x. So you have half e power 2x with boundaries of ln 2 and 0. And again, this has to be added with, this is 16, right? 16 divided by minus 2, because we have this e power minus 2. In that case, 16 divided by minus 2, you'll end up with minus 8 over here. So you get minus 8 e power minus 2x with boundaries of a and ln 2. And again, from this point onwards, we'll just substitute the values of the x coordinates over the situations and for the different equations, and then just calculate it. For example, over here at first you have half e power 2 ln 2 minus half e power 2 multiplied with 0. This entire expression was multiplied with pi, and then again plus minus 8 e power minus 2a, minus would be just positive in that case, so I'll just directly write positive. 8 e power minus 2 ln 2, and again this was also multiplied with a pi in front. So now you have half e power 2 ln 2, half e power 2 ln 2, which is 2, and 0.5 e power 2 multiplied with 0, which is just 0.5. This multiplied with pi, and on the other hand side, minus 8 e power minus 2a, right? That is going to be minus 8 e power minus 2a pi, and then again this one would be 8 e power minus 2 ln 2. This is positive 2 in that case. So now you get positive 2 pi over here. So from the first part, 2 minus half is going to be 1.5, and with 1.5 you can add this 2, right? So you get 1.5 plus 2 is 3.5. So this is 3.5 pi minus 8e minus 2a pi. Again, if I go back to the very top of this question, there was one format given. It was k minus e pi e to the power of 4, 8 pi e to the power of 4. Okay, we will just go back now and I'll write it over here. This must be equivalent to k minus e pi 8 e to the power of minus 4. Maybe I'm making a mistake. 1 minute. 8 pi e power minus 4. K minus 8 pi power minus 4. Right. In that case, I mean, your answer is obviously given in that format. In this situation, the value for your k, right, over here, the value for your k is 3.5 pi. We can clearly see that. And your a was in a power of 8. We should write it like this over here, that 8 pi e power minus 2a. What we get is that e power minus 2a should be equals to minus 4. Right, let me just first write it down over here, that k is 3.5 pi, and e power minus 2a is equals to e power minus 4, which means obviously the bases gets cancelled out. Now you're left out with minus 2a minus 4, and a would be minus 4 minus 2, which is just positive 2. So in that case, the value for your a is just 2, and the value for your k is 3.5 pi. With this, our entire integration worksheet volume section ends. I hope it was clear for all of you. If you guys are in need of the solved PDF or the blank PDF, please email me, or you can reach me in WhatsApp, or you can inbox my page directly. My moderators will try to contact you and give you the PDF as soon as they can. And also, if you're looking for formula booklets or chapter-wise booklets, you have to specifically, inbox us in our Facebook groups and Facebook page at Excel Easy, and you can order our booklets from the page directly, and they will give you the home deliveries and everything from there. Okay, then, thank you for watching the video. If you have any problem from integration volume section, still after this video, you can comment under the video and let me know if your questions are answerable through videos or answerable through comments. Thank you for watching.